Hi guys, welcome back to Depth of ML. Today we'll be solving this question that was there in the sample paper for GATE TA that was provided by ISC in 2024. So let's see how to solve this question. So given the matrix H, it's a 2 cross 2 matrix. One of the eigenvectors is -1, -1. Then the other eigenvector is. So they're asking for the other eigenvector. They have already given you one of the eigenvectors, okay? So how will you find the eigenvectors? There are multiple ways you can actually do this. Let's see how to solve them. So the first approach that I'll take towards solving this particular question is elimination. So I will try to see if I can eliminate some of the options or all of the options and reach the answer. Okay, so for that I should know a very basic thing about eigenvectors, which is that if I multiply an eigenvector with the given matrix H, then I should get some lambda x times that particular vector, right? So basically the vector will either get shrinked or elongated based on the corresponding eigenvalue. So if lambda is the corresponding eigenvalue, then hx will give me lambda x. Fine. So let's see if we can do that. So the first approach is elimination. Let me look at the first option, which is 1 minus 1. Okay, so let me multiply h and let me do hx. So I'll do it for the first option. So another thing that I will use here is the linear combination of columns while multiplying the matrix. Okay, so there are multiple ways in which you can multiply a matrix. Here I will use this linear combination of columns of first matrix. So when I'm doing h of x, it's essentially that when I'm doing 3 minus 1 minus 1 3 into some vector a, b, maybe the coordinates, I will get a times 3 minus 1 plus b times minus 1 3, right? And this really speeds up our calculations. Fine. So let me just start with this and find the solution for this. Okay. So what I'm going to do is I'm going to multiply h with every matrix, every vector, and see what I'm getting. Okay. So I will multiply first a option, so which is 1 time 3 minus 1 plus minus 1 times minus 1 3. Okay, so this is 3 minus is plus 4 and minus 1 minus 3, right? So this is this is 1, so this is 4 and minus 4. Okay, so this is nothing but this is 4 times the vector, the original vector that I multiplied, which is minus 1, right? So this looks like it is an answer, and it is actually an answer, because the other thing that you should check is that this particular vector is not a scalar multiple of this, right? Like in option B, if you will see, it's a scalar multiple of this. So B and this given eigenvector is essentially same, right? So A is the answer. You can go on and check for other vectors and you will find that none of them satisfy this condition except this, but this vector is already equal to minus 1 times minus 1 minus 1. So this is not a different eigenvector, right? So elimination was able to give us the solution very quickly. Let's see the other ways. So if you're not able to get this idea that okay, you can multiply this, or there are multiple options that are satisfying this, then what can you do? Okay, so what will you do is you will go the original way of finding the eigenvalues. Okay, so we'll do eigenvalue calculation. So we'll do 3 minus lambda minus 1 minus 1 3 minus lambda. So this is how we find the eigenvalues, right? We take the determinant of h minus lambda I and we set it to 0. So I'm going to set it to 0. So this is 3 minus lambda whole square minus 1. So this is 9 minus lambda square minus 6 lambda minus 1 is equals to 0. And this will give me I'll just change the signs over here. I'll multiply this whole equation with minus 1 on both sides. So I'll get lambda square plus 6 lambda minus 8 is equals to 0, right? Now I'll do lambda square minus 4 lambda minus 2 lambda minus 8 is equals to 0. So I will get my roots as 4 and 2. Okay. So now I have two distinct lambda values, right? So I want to find the corresponding, like now I want to find the eigenvector, right? So can you observe one thing, that this is a symmetric matrix. So this is a symmetric matrix, right? So a symmetric matrix by spectral theorem, I'll just add it over here. So spectral theorem says that for a symmetric matrix, different eigenvalues or distinct eigenvalues result in orthogonal eigenvectors. Correct? So this is something that is important from the point of view of machine learning, because symmetric matrices are very frequently used in machine learning. So spectral theorem says that if you have different eigenvalues corresponding to a symmetric matrix, then your eigenvectors will be orthogonal. Okay, so that makes my task easier, because now what I can do is I can just take the dot product of this vector with the other vectors and see which one is orthogonal. If there are multiples, then obviously I'll have to do the tiebreaker. Okay, but let's see if I can use this particular approach and solve this. So all I have to see is that, so this is E1, okay, this is the eigenvector 1, and we'll see if we are getting the dot product as 0 for any of the vectors. Okay, so I'll take the dot product of the A option with E1. So this is -1 into 1 is -1, and -1 into -1 is +1, right? -1 + 1 is equals to 0, right? So I think another thing that I should state here is that if vectors are orthogonal, their dot product is 0. Product is 0, right? Except when the vector is 0, but eigenvectors cannot be 0, so the vectors only when they are orthogonal to each other, their dot product will be 0, right? So this is 0, so this is definitely our answer, but let's check the others as well. So -1 into -1, -1 into -1, so we are just adding -1, -1, which is -2, so this is not my answer. Then we'll do 1 into -1, which is -1, and 0, which is -1, so this is also not my answer. And D, 0 into -1 and -1 into -1, -1 into +1, so 0 -1 is equals to -1, right? So this is also not my answer. So using this approach also, I am able to quickly find out, once I have found out that there are two different eigenvalues corresponding to this particular matrix, I can use this. Okay, but there is another way to solve this question, a longer way, in case you don't know about the spectral theorem, and that's where you will find the corresponding eigenvector to the eigenvalue, right? So how will you do that? So first of all, we know that there are two eigenvalues, lambda is equals to 2 and 4, right? So first I should try to eliminate which eigenvalue this vector corresponds to. So what I'll do is I will multiply this matrix with this particular vector, the vector that has been given to me, to see that what is the corresponding eigenvalue, so I can take the other eigenvalue and do the computation corresponding to it. Okay, so -1 times into 3 into -1 plus -1 times into -1 into 3. Okay, so you can very quickly do this in your head. I'm just doing it slowly to show you how every step proceeds. So this is nothing but -4, this is 1, -1 into -1 is +1, and -1 into -3, -1 into +3 is -3, right? Oh, this is actually -3. So this is nothing but -2, this is also -2, this is 2 times -1, -1. Okay, so this vector corresponds to eigenvalue 2. Okay, so I should find the eigenvector. I should find the eigenvector corresponding to 4. Okay. So I have to find the eigenvector corresponding to lambda is equals to 4. So how to do that is that h minus lambda I x should be 0, right? Because x is equals to lambda x, right? So if I take it here, I'll get this equation. Now let me do this. So my matrix is 3 minus 1 minus 1 3, right? And my lambda I is 4 0 0 4, right, is into x is equals to 0. Okay, so this is nothing but 3 minus 4 is minus 1 minus 0 is minus 1 minus 1 minus 0 is minus 1 and 3 minus 4 is minus 1 again, right, into x1 x2 is equals to 0. Now let me use Gaussian elimination to this. So r2 is equals to r2 plus minus r1. So this will become minus 1 0 0 and x1 x2 is equals to 0. Fine. So this is the last, this is the 0 row. So the equation that we are getting from here is minus x1 minus x2 is equals to 0 or minus x1 is equals to x2. Okay, so whatever vector will satisfy this particular, or whatever vector will satisfy this particular equation will be our eigenvector, right? Now we have to go back and look at the options. Okay, so these are the options. Let's see. So we have equation minus x1 should be equals to x2. Okay, so 1 is equals to minus 1 times of x1 is equals to x2. So this is the right answer, and rest you will see that these all do not satisfy this condition, because minus x1 is not equal to x2, minus x1 is not equal to x2, and minus x1 is not equal to x2, right? So we are able to nail down this even though we don't know anything about the symmetric matrices. Also, if we don't know about also if we are not able to eliminate the other options, so we can always go by the long route and solve this particular question. Thank you. We'll see you in the next video.